You cannot hear the voice because I'm using a software that actually canceling the noise around me, and thus I'm not going to be able to share this one. Okay, and this will prevent me sharing the voice with you, the computer audio with you. Anyway, the link of this tutorial is available for you on Canvas, and we're starting with the same introduction we have, talking about the assignment question and how we are going to change the parameters, the solution steps by step by step, and then I start to do the steps of the solution here on paper. So it was you have to make the Mohr circle, show you how to find the delta W, and then we are going to go to find the value for the theta and the value for the FF. So I highly recommend that the student watching this tutorial, and I can repeat something similar to it, but now I'm going to show you much easier way. I'm going to show it to you in a much easier way. So we go to the question once again. We have a material which have the mean value for the bulk density of 735 plus Q. Now we come first to understand what the value of the P and the Q you are going to apply to change your parameters. Now P is your first number of the student ID from the right. For example, if your student number is 175, so 5 is going to be the P. The Q is going to be the last two digits, so 75 is the Q value. And we're going to add these parameters to the parameters we have, the general parameters we have in the question. So every student is going to have different inputs from the others. And this will be the challenging thing. Now, once again, I don't mind that you work together, sharing the experience, teaching each other, learning from each other, but you are going to make your own design procedure. And this will be the most important thing for me. I'm not here to make your life harder. Actually, I just want you to take the challenge by yourself. Okay, so the density will be the first thing will be changed, 75 plus Q. First, you need to sketch the family of the LWC for this results obtained from the experiment by using the Mohr circle, and then find the following. Use the Mohr circle to determine the internal angle of the fraction theta, the maximum principal plane stress sigma 1, and the unconfined yield stress sigma c for each yield LWC. Now, we have 1, 2, 3 sets. So we're going to end up with 2 sigma 1, 2 sigma c for each one. In total, we're going to have 3 sigma 1 and 3 sigma c. How we can do that? By sketching the multiple Mohr stress. This will be the first Mohr stress, second Mohr circle, second Mohr circle, and third Mohr circle. Now, after we finish with the Mohr circle, we're going to tabulate the maximum principal plane stresses sigma 1 and the unconfined yield stresses sigma c for each LWC obtained. Use the data to sketch the flow function, the MFF, simply not FFM, but anyway, the FFM plot to determine the value of the gas. Now, if I'm going to have 3 sigma c and 3 sigma 1, I can locate the 3 points and sketch a line of the MFF. Now, I need to find the effective angle of the internal fraction delta, which can be found graphically by connecting the endpoints of the individual locus by the best straight line that passes through the origin, as we did in the slide 111 of lecture number 2, which is this lecture actually we've been running today, and using the this shear cell to measure the angle of the wall fraction, W. To show you how to do it. And then follow the steps in the design example in lecture number 3 to find the minimum order outlet for both cylindrical outlet and the circular outlet. So again, what we take a look to the results, we have the wall fraction measurement. From there, directly I can find the delta W because I have the normal force and the shear force in two cases. You can see that this one is going to be different from one student to another. And this will direct every student to a different way. And for the delta, we're going to find it. And we're going to find the charts to find the value for the theta and the value for the FF. And then we're going to find the CAS. So the steps of the solution is going to be simply described in this short PowerPoint I'm going to share with you now. Because I need to close the first one. Sorry. Okay, so we're going to start showing this one. And you will actually need to write down these steps of the solution. So for the question number 1 steps, and actually you can write down these things as the steps of the solution in even your submission paper. So sketch the Morse circles to find the tau and the delta, or the sigma 1 and sigma 2 for each set of the test result yield Lucy. Second, sketch the yield Lucy for the 3 tests in a singular graph. So after you're going to find the value for the tau and delta, you can put them the 3 points in singular graph. Start a line from the origin that passes the last point of each line. Is going to give you the value for the tangent delta, then you can find the value of the delta. Okay. And I'm going to show you how to do that, just bear with me. Using the wall fraction measurement to find the delta W, because we already have delta X and delta Y, then we can find the tangent and we can find the delta W value. Now we know the delta and the delta W, then we can find both the theta and the FF from the charts I shared with you. We'll get 3 sigma 1 and 3 sigma C. And we're going to use these data to sketch the MFF graph. And then we're going to use the FF value we found. We found 2 values. One is going to be for the conical outlet. The other one is going to be for the symmetrical outlet. And then we're going to sketch 2 1 over FF. We are going to find 2 values for the CAS. One is going to be for the rectangular, and the other one is going to be for the circular outlet. Now, I can find the CAS's value, find the H theta twice, one for the symmetrical, one for the circular, find the D minimum. Now, I would like to, I'll try to put that on paper to explain to you step by step if you're going to be lazy actually to check the recording. On the camera right now. No, my camera is not good. So instead of that, I'm going to show you the marking sheet I used to use. And this will give you even a clear solution steps than what we have. Again, the video on the canvas show you everything. I'm going to share this thing here just in case if you are lazy to search for it. I'm going to where I'm going to put it. I'm going to put it on the main Teams page. Okay, so slow. I don't know where my mouse is. I'm using 4 screens at the okay, so I'll write down here that at general Okay. So maybe I'm going to make it once again on the paper, but the problem is that I cannot do it now because, as I told you earlier, I brought the wrong camera. I can do it with the phone, but I was shocked actually that the quality of the recording on Teams with the phone was horrible, as I found today. So as I told you, again, to use the Excel sheet I'm using for the marking to show you the steps of the solution graphically. So the step number one is first sketch the Morse circles to find the sigma 1 and the sigma c for each set of the test. That means you need to make 3 more circles. 3 more circles. 1 for each set of data, day 1, day 2, and day 3. So from there, that's what we need to do. Actually, we have the, well, I'm going to show you that once again on the canvas. As you can see here, we have the normal stress and the shear stress. So we have the sigma and the tau. So we're going to make sigma and the tau against tau for every day, for 3 days. And we're going to have this line. Make the Morse circles, and the intersection of the far side of the Morse circle is going to give me sigma 1 and the sigma c. So we are going to have the sigma 1 for day 1, day 2, day 3, and the sigma c for the day 1, day 2, and day 3. Now, how to make the Morse circle using the SolidWorks? You already have a video. You can watch it and start to do it for the first one and see how good you are in it. It's not that hard, and I'm going to, as I said, I'm going to run a step-by-step session for it very soon. Now, we got the 3 points now. When I say 3 points, because we are going to sketch the sigma 1 against the sigma c, right? Now, what we're going to do is, I'm going to put the sigma 1, the sigma against tau for the 3 days in one graph. Okay, so this will be the test for the day number 1, day number 2, and day number 3. You will find out that I can sketch a line starting from the origin, and it's going to be passing the last point of each of the 3 curves. This is not the skull, okay, but we can do that. And then once again, we can do that with the SolidWorks. And then we can find what will be the angle of this curve. This angle is the delta value. Okay, this will be the internal fraction angle, or the effective angle of the internal fraction. Step number 3, we're going to use the data we have for the wall fraction measurements, and we can find the delta W, which is going to be tangent inverse of the delta Y over the delta X. So you can see actually here the value were 4 and 2, but for you I made some changes just to make some more challenges. So I made these changes. You can see that for the normal force, instead of 2, I add 2 plus p over 10. That means if your p value is going to be 1, that means this one is going to be 2.1 and this will be 4.1. Honestly, that's not going to change anything. Here we are going to have also the same value to be added on. So the changes mean nothing if you just try to think logically. We're going to get the value for the delta W, okay, and then we are going to go to the charts by knowing the delta and the delta W, and you can find the value of the theta as we mentioned earlier. You locate the delta W, you locate the curve for the delta, and you start to make the intersection first, the horizontal line. You're going down, find the theta, you're going up, intersect with the delta line once again, and you go to the left, to the right, sorry, and find the value for the FF. So we are going to find value for the semi-included angle, theta, for the rectangular outlet and for the circular outlet. The same thing for the Fm, we're going to find the value for the rectangular and value for the circular. And they are going to find these values in the step number 5 using the data on the table to sketch the sigma 1 versus sigma c. As you can see here, we have 3 points. That's why we're going to have 3 points. And we sketch the 1 over ff line. Now, if you're going to have the lines, it's going to be here and not intersecting with 1 over ff, the only thing you need to do is just extend this line. Extend this line to the left. Have the intersection, find the CAS value. So we're going to have 2 curves. We have 2 CAS value. One is going to be for the circular, the other one is going to be for the rectangular. Now we have the CAS, we have the theta, do the calculation and find the outlets, diameter and length. Are the steps clear enough for you guys?
Yes, sir.
Now, the video is recorded.
So I just want to redo all these 3 times, right? Like each step has to be done thrice because we have 3 different sets of data.
Each is, well, here we're going to do this step 3 times because we have 3 days testing. This one need to do once. This one need to be done once. And this one need to be twice because we're going to have the rectangular and circular. This one need to be twice, to be done twice because we have 2 1 of value. And this need to be twice for the circular and for the rectangular. And the diameter need to be done, and the W need to be done. So you are going to have just the more circles need to be done 3 times. All the other steps is going to be a parallel design. One for the rectangular, the other one is going to be for the circular shape. Now, the other question we're going to have is straightforward because I gave you the CAS. I gave you the delta. I gave you the delta W and give you the density. So you just need to use these 2 parameters to find the value of the theta, and you can find the diameters here. Okay, just find the common diameters. Question number 3, again, is going to be almost the same thing. We have the delta given, we have the delta W given, and here, well, this will be a challenge. I'm going to explain this question for you next week. You can see that we are going to have a relationship between the DC and the D1. Okay, we have a relationship between DC and this D1, and we are going to need to find these values, this equation, to find the CAS, and from there you're going to make the calculation. I will leave this one for next week. The question number 4 is giving me about the design for the Cylon. If you remember the Johnson equation, we're just going to apply Johnson equation for this diameter and that height. Okay, and that's it. I'm going to apply it to find what will be the pressure we are going to have at the bottom of the Cylon. So the other 2 questions, 2 and 4, straightforward. I'm going to explain this question for you next week when we're going to do the lab session. And for the question number 1, we have this tutorial is already been done from last year, step by step on paper. I'm going to prepare for you the step-by-step tutorial for using the SolidWorks to make the Moore circle. This should be done very soon, actually, anytime this week. If you need any help with the question number 1, inform me before Thursday, so we can run on Thursday evening, maybe by 6 to 7 p.m. That's the only time I have free. So I'm going to be more than happy to meet you once again and give you more information. But what I would like you to do is that I know this is week number 3, and I think that you have some inquiries in our subject. But I would like you to, starting tomorrow and the day after, uh, working on the assignment number 1, question number 1. So we can simply give you more support before it's going to be too late. For the due date, I didn't put any due date on the sheet here. I said that for the submission according to the UTS online dates, and I didn't put the dates because this will be something flexible between me and you. I'm going to allow you to submit when you tell me that you are ready to submit. Okay, so I'm going to stop the recording for the third part. Unless if you have a question, it's going to be useful for the others if you ask it right now. So, do we have any questions? All good? Okay, so it was marathon day today. I've been talking to you for 6 hours, and I think that actually we should stop talking to each other. I don't mean permanently, at least for today. Okay, so thank you very much for your attendance, and